I have seen amazing things occur from the use of compost. We've been able to arrest tree decline and also suppress disease.
This project is at its heart a circular economy project, which means that we're shifting systems from being linear to being circular. So in the old ways, we took our food organic and garden organic waste and put it in landfill. So now we're being regulated rightly to turn that into a resource, a compost, and create a more circular outcome where something that was considered a waste is now considered a resource. Sustainability Victoria has funded us through their Circular Organics Council scheme to look at different ways that we can find end uses for our compost, particularly through circular procurement, and that's using our compost ourselves.
This is trying to identify a localised circular solution supported by SV in a partnership with Gaia Envirotech as well. So it's a three-way partnership which ultimately we expect will provide significant benefit for the Hepburn community, but for all local governments across the state.
And we're also looking at how do we get the best possible quality compost from that collaboration.
So you can measure bricks in plants, so you can measure the sugar.
Matthew Daniel brings a rigorous science lens to the work, so he has designed a trial with a control site and with lots of testing so that we can know with confidence how beneficial the compost is and what settings provide the best possible response for compost in our parks and open spaces.
We are in an area of historic mining, so we have a lot of degraded soils throughout the Shire. I consider myself a holistic arborist, where I consider the soil profile, the growing conditions that the tree grows in, as being a key element to be successful in how we manage trees in urban environments or establish trees in urban environments. Our project is really demonstrating a novel approach to quantifying what site soil health is, and then what impact different uses of applying compost will have on that site soil, and the benefits that we gain from improving soil health through improved plant performance. Our project is trialling the use of compost in multiple ways. The first way is in when we plant trees, incorporating that compost into the site soil. The second way is with established trees, where we're applying the compost to the soil surface, then applying a layer of mulch over the top of that to protect the compost. And then the third way that we're using our compost is making compost tea.
Liquid inoculum that is really easy to use in horticulture.
So Hepburn Shire Council has been working with Gaia Envirotech for a number of years to bring on board composting in our shire through an in-vessel composting system. And now, since we've collected food organic and garden organics at curbside for the last year, we've increased the scale and the opportunity there.
The optimisation process in our project has been a key component.
We wanted to see with this project about where are the most effective levers to tweak and push, where we can increase the quality of the compost. A couple of parameters we shifted were the amount of turns that we do, so the actual mixing of the compost through the process. Each mix reblends a material, reincorporates moisture, moves less graded material to other areas of the pile, so you get more efficient biodegradation. And the other side of the coin was the moisture content. So a lot of composting is done without moisture sort of augmentation.
We found early on that we could improve in getting more moisture into the product throughout all of the different processes.
We originally started the project applying moisture during our turning only via the equipment, and it wasn't quite sufficient to get that quality. And so what we did on site was install some automatic sprinklers, which was reasonably simple. We added moisture at different points and for different periods to see what optimising that would do to the final quality of the compost.
Microbes are living organisms. They require water the same as humans do. So it's really important that we maintain good moisture levels and good temperature levels, so that as we move into the maturation phase of our compost making, that we're getting as much microbial diversity into the product as possible.
Generally, it's improved on all accounts, and there's been some fairly simple changes to our process that have allowed us to do that. Guy has developed some valuable insights into how we can tweak our process to modify the final product. Agricultural, the features they want in their compost is quite different to, say, a market gardener. And so we really like councils to figure out what they want to do with their organics, what value they want to realise from that material.
We're measuring the bacteria, fungi, protozoa and nematodes that are contained in our compost, and that gives us a really good indication of the quality. The microbial component of compost is a key attribute of compost quality. As an arborist, we look at a tree and we do a visual tree assessment, and there are lots of cues that we can see in a tree visually that help us understand the tree and help us understand what we need to do from a maintenance perspective. But with soil health, you really need to measure certain aspects to develop a good understanding, so that then you can apply methods with using things like compost to improve that soil health and get greater outcomes in tree performance. It's a novel approach in measuring physical, chemical and biological attributes. With the physical attributes, we're using instruments to measure compaction and moisture that assists you in your decision making of how you're going to improve that soil health. Just putting compost down onto really highly compacted soils may not work. There may be other methods that you need to apply in the meantime. In our lab analysis work, we're measuring soil microbiology, so we're measuring the bacteria, fungi, protozoa and nematodes in the soil and the mycorrhizal colonisation on the roots. And we're also measuring the chemistry, the total available and exchangeable nutrients in our initial baseline soil health assessment. What we found was that the soils that were heavily degraded from historic mining activities were much worse than I anticipated. And then we had sites where we assumed that soil health would be higher, and what we found was that those soils also had degraded soil health. Our study is a longitudinal study, so we are measuring a whole lot of aspects over time. Our baseline is really good. It's a really valuable baseline. We have an interim measure, and then we have an annual measure. What we've found already anecdotally, the soils have slightly decompacted. The compaction rating is lower than at the beginning, and we're already starting to see some signs of additional microbial activity. We're seeing some mycelium growing throughout the material. We're also seeing some worm activity, and that's often a sign that we're increasing microbial activity.
We've had a lot of fun communicating this project to the community. We've done a number of different little short videos introducing Matthew as a caricature, as a master composter, and some cute sort of science animations to really help people understand what compost is and to bring them along the journey of how we're making it, what we're finding. The contamination challenge that we have is something that we really need to close the loop on with the public too. We are here with Chantel, our resource recovery coordinator.
Plastic bags, biodegradable bags, we don't allow them into our food and organics bins.
As we invite people into this journey, we're also saying you're part of it. You're part of the circular economy by not contaminating this resource you're giving us. And also, thank you very much for that resource. When we got to the end, we allowed people to come and collect some of that compost and try it out for themselves. And we look forward to hearing what people do with that compost and what they find. Looking at the economic costs and benefits of applying compost locally, we see that we get real cost savings in our parks and gardens operations to start with. The much higher success of tree establishment and tree longevity means less money spent on rescuing trees, on planting new trees. There are also economic benefits that we might not be able to attribute a monetary value to that aren't immediately seen as cost savings but are clearly beneficial, such as having trees, more trees that provide shade in heat waves and are able to withstand withstand the impacts of drought and heat waves better. Everyone in the Shire has access to our parks and gardens and our street trees. And so that's when most people will be able to see the amenity, heritage, biodiversity, and climate resilient impacts of that tree health.
Soil health really is a new knowledge frontier, and we ignore it at our peril. Soils in most of our urban environments globally now are highly degraded, and globally we understand that we need to develop canopy cover in our cities and our regions to reduce the effects of climate change for people and the negative effects to biodiversity that we've had through urbanisation.
There's a massive opportunity there to use these materials to reinvigorate and regenerate soils in areas that require it.
We're in a space of innovation and learning overall. The industry has a lot to learn. How do we do this best as councils? How do we work with the compost industry? How do we work with new emerging companies and technologies that are being offered?
We are really in the early stages of developing standards around how we use the material.
Probably 90% of the composting or more that happens in this country is aimed at waste elimination or waste reduction. Everyone in the project, no one's mentioned the idea that we need to get rid of this waste as quickly as possible or as easily as possible. Everyone's pushing towards, I have a use or I have an idea for the use of this product.
One of the key learnings is how important it is to measure the quality of your compost, because therein lies a story, and a story that you then need to unpick and discover where your system might need tweaking, and also where, understanding where you need to get to in terms of optimal outcomes and soil health outcomes. So that's a journey. It will be a long journey, and as we go, I guess the challenges have been trying to condense this work into a short space of time, knowing that really it's going to take probably years before we feel that we have the results that we know are possible.